Hello, hello, and welcome to the final workshop of today, our Hardhat upgrades workshop. Now, this is an incredibly powerful workshop, and we're going to go over exactly how to make your smart contracts upgradable. This is another one of these workshops that is newer. This is some newer tech, but this is the tools that a lot of the top projects use to make their protocols, upgradable. And interchangeable. Well, okay, not interchangeable, but upgradable, right? And it gives them that flexibility to move on the fly and do different things. And if you watched our DAO workshop earlier, you can use the tools that you're going to learn here with your DAOs to make your entire DAO, your entire protocol, completely customizable in a decentralized manner, which is incredibly powerful. So, hello, welcome all to the chat. I'm seeing everybody here in the chat. Hello, hello. Again, feel free to ask a ton of questions here, right? These sessions are meant to be collaborative and meant to have questions asked, because this is definitely some cutting edge stuff that we're going to go over here, and it's going to be a ton of fun. So with that, let's go ahead and jump into what we mean by upgradability. And let me just pull something up. Once again, Open Zeppelin has done a ton of fantastic pieces of content on this exact topic. For those of you who haven't read this, this blog is still very current. It's called The State of Smart Contract Upgrades. And the demo that we're actually going to be following along is this one. We have a little bit of the code that we're going to go over is a little bit different than the link that I just posted, but it's basically the same thing. We just went ahead and added our own flair to it. So, and this blog is really, really good. So when we talk about upgradable smart contracts, a lot of the time say, hey, aren't our smart contracts, immutable? Isn't it there forever? And yes, this is the case, but we have functions, for example, that we can call, right? If I call the store function on some simple storage contract, I can change the value based off what I call, right? In the same context, we can actually call other functions basically to point our calls to different smart contracts, right? Like if there was a function called change contract implementation, we call that function and we would change the contract that we're actually working with. And all this power comes in from a couple of really powerful low-level codes, one of the most important ones being delegate call. And we'll talk about that in just a second. So let's flip back here. Let's flip back over here and let's actually just jump into the code. And as we move along, I'll show you what we're talking about here. So we're jumping right into it. Again, if you have questions, comments, feel free to just ask away. I know a couple people might still be thinking, hey, like, wait, upgradable? Wait, what are you talking about? How do you make your contracts upgradable? Don't worry, you'll see. Things will make sense here. So the first thing that we're going to do is we're going to set up a Hardhat project. Now, if you don't have Hardhat installed, once again, definitely check out Hardhat. Set up Chainlink. I'll put the link here in the description. Definitely follow along this tutorial here. And then also, actually, sorry, before I jump into this again, I have a video on this topic as well, where I go really in depth into kind of upgrades and how they all work and everything. So here's a link to that video as well. This video also does it in Hardhat too. So that's really good. Anyways, and one more thing, sorry. I have a million more things. This is going to be what the full code ends up looking like. So I'm going to go ahead and post this in the comments as well. I know I just flooded you with links, but if you want to just fork the code or git clone the code, this is exactly what we're going to be going over and exactly what we're going to be doing. But okay, with all that being said, let's go ahead. Let's run through this project. How do we actually upgrade? How do we actually change our projects in the future, right? How do we make it so that if we code some disaster in there, we can fix it. If we want to make something totally different, we can change it. Let's go ahead and learn how to code that. Now, to get started, we're just going to do our classic MPX Hardhat. and this will get us set up. It'll say, hey, what do you want to do? Let's create a basic sample project. Yep, it'll be there. Great. And this is how we're going to get started. So I've done some demos where I've done the TypeScript, I've done the advanced. I'm actually a big fan of using TypeScript. However, yeah, the code is very fresh. Yeah, I was pushing a couple changes like 10 minutes ago just to make sure everything worked and everything was up to date. My original version of this was actually in 0.6 of Solidity, so I updated it to 0.8, added some better tests and stuff to make sure you had the best materials available. But yeah, so we're going to be installing a basic Hardhat project just to get going. And I'm going to talk about the different types of upgradability as we kind of go along here. So I know a couple people already kind of in the chat said, hey, like, what are you talking about? I'm definitely shilling TypeScript. Yes, Jeff, definitely shilling TypeScript. Yeah, as we go along, I'll explain basically what's happening. So great. So we have our new contract. We have our new project. Awesome. What we're going to do now is we're going to add the the Open Zeppelin upgrades plugin. So they have an Open Zeppelin upgrades plugin. I think if you go to the docs here, they have this plugin here, which again, I'll drop this into the chat, which gives us a really nice interface for working with these upgradabilities. They make our lives a lot easier. So I'm just going to go ahead and copy all this. We're at Open Zeppelin Hardhat upgrades, Nomic Labs Hardhat ethers. We're just going to do yarn add, boom. I think I might already have this one installed. And if I don't have ethers, I should have ethers installed, right? Ethers, yeah, okay, ethers is already in there, great. So, and these will give us an API to actually just wrap everything up into, contract.upgrade, right? And that's how we're going to do our upgrades, as opposed to us having to write all these proxies and stuff, which we will talk about in a minute. We are going to do this on the Rinkeby testnet. However, I do recommend testing locally. If we have time, I'll show you how to test locally as well. So, okay, cool. So now that we have everything installed, we can come over to the config, and we can make sure everything in here is what we want. So we need to require that upgrade. So we'll do require at open zeppelin /hardhat grades. That's in there. Okay, perfect. Let's scroll down. We'll have this use 8.2 of Solidity. Perfect. Okay. Next, what we'll need to do, oops, let me actually switch. Let me switch to this. Sorry. I have my sample code in the back. I don't want that in the back. I want that myself. Okay. What we're going to need to do is we're going to add our networks in here so that we can actually work with the networks that we want. So we'll do networks. Hardhat is going to be our main one that we're going to do all our testing in and stuff, but we're also going to do Rinkeby. So for Rinkeby, we need a URL, which is going to be our Rinkeby. It's going to be process.env.rinkeby RPC URL. This is going to be an environment variable. Once again, in a .env, you're going to need your Rinkeby RPC URL. You're going to also need your private key environment variables. Equals blah, 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 equals blah, 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 blah. Again, if you're unfamiliar with this, if you're unfamiliar with all these, the Hardhat starter kit, I'll put this, look at all these links. I'm giving you all this free alpha here. The Hardhat starter kit also has some instructions on how to set up all these things, how to set up a private key, how to get, Kovan RPC URL, Rinkeby RPC URL, all that stuff to get your stuff up to date. I'm going to go a little quickly over this just because you can read all about it in that file there. But we're going to do process.env Rinkeby RPC URL. And we're going to do accounts is going to be it's going to be process.env.private key. Okay, wait, is that right? Just doubly sure that that's correct. Don't need the brackets. All right, cool. All right, much better. All right, so we have a way to connect to the blockchain. We have an account. Perfect. So now that we have our account set up, let's go ahead and create our contract that we're going to use. So we're not going to go over, what this contract is doing. I am just going to copy paste this. This is a contract called Box, and here is the whole contract, right? So I know I copy pasted it. Don't worry, I'm going to go over what it's doing, right? It's not doing a whole lot, right? So we go ahead and deploy this contract. It's got an event here. It's got this private variable value. We can get that value with our retrieve function. We can store values in it with our store function, right? All this function is going to do is update our value, and that's just going to emit a function here, right? Pretty straightforward. So this is going to be our starter contract. And when we deploy this to the blockchain, you think, okay, cool. At that address, this is always what's going to be there, right? This is the code. Well, this is what we're going to do, though. We're actually going to upgrade this to box v2.sol, okay? So we have our box 1, and we said, this is a cool contract. However, we forgot to code in some functionality. Like it would be great if we had an increment function that would just add 1 to that value every time, right? Because right now we can call retrieve, we can call store, but we have to know what value was before. I wish I had more functionality. I wish that we had deployed this new thing. So in box v2, we're going to add a function called increment. It's going to be a public function. And all it's going to do is we're going to say value equals value plus 1. We're also going to emit one of our value changed events with value. So this is going to be the new functionality that we're going to add to our smart contract, right? We are going to upgrade our smart contract from having no increment function and being this box contract to having this increment function, right? This is going to be this upgradable function. Going to pause real quick, look at some questions here. No, I don't love JavaScript. However, I do love Hardhat. I do really like Hardhat. Hardhat is great. I will do my best. Thank you. Please save this video too so we can rewatch. Yes, absolutely. Yes, we will save them all. All right, cool. No questions. Yeah, if you have questions, feel free to ask. Great. So these are going to be our contracts that we're going to do. Okay. We could write some tests for this. We're not going to write some tests for this for now. We're going to go ahead and create our deploy script and show you what it looks like to deploy these contracts. We're going to create a new script. We're going to dump this one. Goodbye. And I know we've done, if you've been following along, we do Hardhat deploy a lot. We're not going to use Hardhat deploy for this. We're just going to use a regular deploy script. But in the script, we're going to create a new script called deploy.js. This is going to be the script that's actually going to deploy our contract. So, so let's just go ahead and do the starter stuff. What can you not? VS Code, please don't. Thank you. Main dot then it'll be a function here. Process dot exit 0. This is really just some boilerplate stuff. Dot catch error. Go like this. Console dot error. Process dot exit. Right, and if you're like, wait, what did you just do? You can just go to the Hardhat docs. They pretty much, this is kind of the suggested setup to run your main function. Okay. You can just copy paste it. You don't actually have to know this, but in any case, let's create our main function to deploy this contract. So we'll do async function main And here's where we're going to deploy our contract. So first we're going to do const box equals await ethers, and we can use ethers. Oh, okay. Well, it's going to go ahead and import it like that. Ethers.get contract factory box. So we're getting this box contract factory. Okay. So now that we have the box contract factory, that's what we're going to use to typically deploy it. However, we're not going to deploy box like we normally would, right? Normally, you just go ahead, you deploy box, you go, okay, great. I'm going to move on with my life. We're going to deploy a specific, in a specific order with one function, okay? So first, we are going to deploy box. We are going to deploy box. There will be a box contract on chain. And right after that, we're going to deploy what's called a proxy admin, okay? And if we go to the Open Zeppelin contracts, Open Zeppelin contracts, GitHub, go to the Open Zeppelin contracts, go to contracts here. We go to proxy because we're going to be using a proxy. You'll see why in a minute. Transparent proxy admin. This is what we're going to be deploying next. So we give our box code, our box upgradability to the authority to whether or not to upgrade to this proxy admin. Okay. Doing this has a ton of advantages. Having your smart contract be an admin allows you to kind of set access parameters. It allows you to do a lot of things. So we're actually going to set a proxy admin contract. We're going to set a contract to be the owner of the box. We don't have to do this, but that's what we're going to do. And then finally, we're going to deploy a proxy. Now, what is a proxy? Well, what's going to happen when we actually call, when we call on the box contract, we're actually not going to call directly to the box, right? We're actually going to call, like if we make a call, we're not going to call the box. Like this is not what we're going to do. When we make a call, we're going to call to the proxy, which is going to call to our box, okay? And it does a very special call here called delegate call. And this is a low-level functionality. And if actually we look in the Open Zeppelin code here, if we look in their transparent upgradable proxy, delegate, excuse me, it's not in here. It's in here. Delegate call. In here, they have all these delegate call things. Now, this is a really special function. What it does is it allows us to call this box contract. It allows us to call any of the functions that box has, but pretend that proxy has them. So I'm going to say that again. It allows us to call any of the functions box has, but we pretend that the proxy contract has them. So if I'm some random contract, if I'm a random proxy, I can call store, and guess what? Instead of storing this new value in the box contract, I store that new value in the proxy contract. So I call a contract, I call a function, but I pretend that I have that functionality, right? And that's exactly how these proxies work, right? We use this delegate call function to do this. So we have a proxy contract, oops, and it'll point to what's called the implementation contract. In this case, it's going to be box, right? So we have a proxy contract that's pointing to this implementation contract called box. And if we call delegate call, we call it on the box contract. When we want to do an upgrade, what does this mean? Okay, well, whenever we make a call, we still call the proxy contract because it's going to be the exact same. But when we want to upgrade, all we do is we point to a new implementation of box, or in our case, box v2. We point to a new implementation, and now when we call delegate call, call it on the new box or the new implementation, right? So all we have to do is call some function basically that changes where we make these calls, changes who we make this delegate call to. Anybody have any questions about that, about how we're actually going to do these upgrades here? I know this is a little nuanced and it might be a little tricky to wrap your heads around. It is okay. Or is everybody here saying, I got this? That makes perfect sense to me. I'm looking at you, chat. StreamYard is probably being a little delayed and is not giving me the chats right away. Or everyone is dead silent. If everyone is dead silent, we can move on. Just wanted to see how people are doing here because I know this is a little tricky subject. Kind of makes sense. Too beginner for this. Okay. All right. Well, we'll see it in practice. We will see it in practice here. Okay. So this is essentially what we're going to be doing. So right now, doing all these together, we actually can do it in one function call. So we can create this proxy contract equals await upgrades dot deploy proxy, and we're going to deploy the proxy on the box with an initial value of 42. And we're going to say something a little interesting here called initializer store. Now, what is this initializer thing? Well, whenever we make an upgradable smart contract, we are not allowed to have constructors. But you can have constructors. It's just there's a good chance that that will screw things up. Okay. So what constructors will, the reason we can't have constructors is because constructors have the abilities to set state, to set storage. And one of the cool things about these upgradable smart contracts is all the storage actually gets saved in the proxy and not the implementation. So if we have a constructor that sets some things into the implementation storage, it doesn't get saved in the proxy storage, which is what we want, right? Because every time we upgrade, anything that we had saved in the implementation is lost forever, right? Additionally, you can get into something called function selector conflicts, function selector clashes, and state variable clashes, which we can talk about later. But there is no constructor. You can't have a constructor because that's going to ruin where the state variables are stored. So instead, we have something called an initializer. And what we do is we can deploy this contract, and then after it's deployed, we'll just call store right away, right? That way we don't need a constructor. And this is helpful because when we upgrade our smart contracts, we can say, hey, the initializer is store. Maybe you want to start with some initial value whenever you do some upgrade, right? And we pass the parameters to it like so. We just do a list. And the only one we're going to do is 42, right? So we're going to initially start with 42. And so if we wanted to, what we could do is we could say const initial value equals await proxy dot, what's the initial value here? Proxy dot retrieve. We do console.log initial value. This is Python syntax. Sorry, I'll do JavaScript syntax. All right, so let's go ahead and try to run this. So we'll do npx hardhat, run scripts, deploy. We'll do it on the Hardhat network. See if this works. Ethers like get contract factory is not a function. It's a little mad at me. There and add ethers. Ethers is important to have in here. Spelling is important to do. Let's try again. Oh, actually, I need to get rid of this as well. Oops, and sorry, it's confused because box and box v2 have the same name. Let's call this box v2. Okay, so I needed to get rid of ethers. Oops. I need to get rid of ethers at the top, and I need to use box and box2. One more time. It's always getting mad at me, huh? Network, Ring B. Right? Are my packages right? See if my packages are wrong. There's a good chance I have an outdated package, which would be no bueno. The requested contract was not found. Sorry, 1 second. Okay, yeah, sorry. The artifacts was a little mad. Okay, that's right. So what was happening was, let me actually, yeah. I had some previous artifacts in there. So Hardhat was like, wait, what are you talking about? That contract doesn't exist. So sorry about that. You just need to delete artifacts here. It was looking for something that wasn't there. So one more time. Okay, npx Hardhat run scripts. Well, great. Now that I know that, now I know what that is. Hardhat run script deploy.js. It's going to spin this up on a local Hardhat network, and it's going to do that in .toString. Let's do it like this. Let's run again. 42. Okay. So the current value is 42, which is great because that's what we set it to be. Awesome. Okay. So now we've deployed this contract. Okay. So what we can do now is we can go ahead and let's even see what this looks like when we deploy it to Rinkby. So we're saying, hey, cool. Okay, it's 42, but what does this look like on chain? It's actually 3 contracts instead of 1. So we're going to do npx run scripts deploy network Rinkby. And we're going to go ahead and deploy these on chain. Need to solve the following npx run. Interesting. I didn't know that was an important package. Just ran this, right? Mad at me again. Why are you mad at me? Sorry, team. Oh, did it re-add ethers? No. What's my Hardhat config look like? Apologies again. So confused. It's so mad at me. npx Hardhat run scripts deploy. Oh, okay. Well, now it's at the packaged up lock, which is fine. Okay, now it's happy again. Work rank be. All right, cool. So now we're actually deploying. Sorry, team. Yeah, I kind of want to make some Stack Overflow questions for that. That's perfect. Yeah, so this is my hodgepodge of Hardhat config, but you can use the code that's in the GitHub repo. Ran into a couple bugs here, but yeah, so we're deploying this right now. And actually, if I go ahead to Etherscan, etherscan.io, I'm going to grab my address. Let's put the bumper in while I put my fake password on here. Great. Let's go back to the stream. Pop my address in here. What we're going to see is we're going to see me having deployed about 30 seconds ago a contract, right? And actually, we're going to be deploying a few contracts. And it looks like they're all deployed. So this is that first contract that I deployed. Now, if we look at it, actually, let's look at all the contracts that I deployed. 1 minute ago, 45 seconds ago, 30 seconds ago. Okay, perfect. Contract created, contract created. So these are the 3 contracts that we created. We have this one, which has nothing right now. We have this one, which is verified as a transparent proxy admin. And then we have this one, which is also verified as a transparent or an upgradable proxy. The reason that these get auto-verified is because Etherscan has seen these so many times that it goes, okay, I already know what these are, right? The only one that wasn't verified was the box contract. So this is our box contract. This is our proxy admin, and this is our proxy. So if we go to read contract for the proxy, we get nothing. If we go to write contract, though, we can see there are a couple functions added in here. We have upgrade to and call, upgrade to, implementation, change admin, and admin, right? And if we were to grab our transparent proxy contract address here, what we could actually do is we could actually jump into our Hardhat console and make calls to it, right? And you'll see if we make calls to the proxy, that will be, it'll give us the box responses, right? So we'll do npx Hardhat console -- network Rinkeby. We're in our shell now. We can do const box equals await ethers.get contract factory box. We can say const box equals await box.attach. And we'll paste the proxy in here, right? So again, this is the proxy. This is our box. We're pasting the proxy in here. And if I do await box.retrieve, it's actually string it, .toString, get 42. Why do we get 42? Because this proxy address is now going to be our permanent address. And all we have to do to upgrade our smart contract is switch out the implementation. So we just change where it points to, right? That's all we do. And we change where it points to with our proxy admin here. Something that that's really cool too is, maybe you are creating a DAO, right? But you don't have the engineering chops at the moment, or you're in beta and you don't want to build a full DAO yet. Maybe what you want to do is create a trusted multi-sig. So what a lot of people can do, and what a lot of people do is they create a multi-sig. You can go to Gnosis, create a multi-sig, and we can do exactly that. So let's open up the app. And what a multi-sig is it's a what a multi-sig is, it's a wallet that needs multiple signatures, or can have multiple signatures to interact with it. Okay, so we're going to be on Rinkeby. We're going to go to Rinkeby here. Selection, and we're going to create our multi-sig through Gnosis here. So we're going to go ahead, we're going to log in, we're going to connect here. We're going to go ahead and create a new safe We'll call it box proxy admin. Go ahead and start. And we'll say the owner is just going to be one right now. This is where you'd add, many people for your multi-sig. We're going to add just us. We're going to submit. And this is going to create our new multi-sig contract on chain, right? Definitely super powerful. We do need to wait for a couple transactions for this to go through. But once we do, we'll have our multi-sig up. And this can be kind of your way to do these upgrades without having to build kind of a DAO, build everything like on chain. So we go ahead and hit get started. It'll load up that contract that we just deployed in the UI here for us to use. And I'm actually even going to show you how to transfer ownership to your new Gnosis safe, right? You don't have to. And in fact, the code that I gave for this demo, right? This code, it doesn't have that in it. It's going to assume that you are the ones to keep it, but you can absolutely upgrade and change to having a Gnosis multi-sig. And actually, time-wise, we might be a little short on time. I'm actually going to copy paste the transfer function in here just so you can take a look at it. Transfer to multi-sig. Yes. If this is something we want to do, so we copy the clipboard, paste it in here, and we would just do this. We would just do upgrades.admin, transfer proxy admin ownership to our Gnosis safe, and that's it, right? And then only the Gnosis safe could be the one to do upgrades, to make new proposals, etc. Right? But we're not going to do it. We're just going to keep going because we're running a little short on time. Now, typically, you do want to do something called a prepare upgrade, right? So OpenZeppelin does have this function called prepare upgrade, where it goes in, it looks for some of these function selectors, and make sure that make sure everything looks good. We're going to skip over that as well. We're just going to go ahead and deploy our new box, right? But again, all of this is in the GitHub repo. So yeah, you can take a look there. But let's go ahead. We'll create our upgrade.js file. We're just going to copy paste that main syntax at the bottom. And then let's go ahead and create this upgrade. It's real simple, I promise. Async function main. Function main. Do const box v2 equals await ethers.get. No, I don't want you ethers. Get contract factory box v2, right? So this is the contract factory for this contract, which has our new function of increment, right? So we're going to do let box equals await upgrades.upgrade proxy, and all we have to do is give it our transparent proxy address. So then we just give it that box v2 we're going to say oh, excuse me, it's the box address. Sorry, it's not the proxy address. So we're going to give it the box address. Upgrades.upgrade proxy. We give it the box address, and we say we're going to upgrade it to box v2. And now box, what this upgrade proxy function does, it comes from that OpenZeppelin thing, is it says, okay, that's the old, or excuse me, oh no, it is the proxy. Yeah, that it wouldn't make sense for it to be the implementation DOI. So what it does is it says, okay, this on our proxy contract, we're going to change the implementation to a box v2 instance. So we deploy a box v2 instance. We change our proxy to point to this box v2 instance. And now our box contract, if we do, we should be able to do await box.increment and const value equals await box.increment, and then console.log value.to string. Now if I do px hardhat, run scripts, upgrade, network rank B, let's see what happens. Get contract factory is not a function because get contract factory is a function. Upgrades.upgrade proxy is not a function because upgrades.upgrade proxy is the function, not poxy. Spelling is important, everybody. I should spell things right. So now we're running this upgrade script, right? And this is exactly what's happening. So we're actually going to jump back in the terminal in a second, excuse me, in the console, and we're going to see, even with this same proxy address, we can call increment, and we can call this new contract, right? So this old box address is now, it's meaningless, right? Because our proxy doesn't point to it anymore. And in fact, if we go to proxy transactions, if we wait a little bit, pretty soon on our proxy and our proxy admin, we'll see, a function go through, right? Once this goes through. So value. Oh, duh, because box.increment doesn't actually increment anything. Excuse me, doesn't return anything. I would have to call retrieve again. But we'll do npx hardhat console -- network rank B. We'll jump in here and we'll do const box v2 equals await ethers dot get contract factory box v2. And then we'll do const box lowercase box v2 equals await box v2 dot attach. And we'll use this proxy address again. So it's the exact same one, right? And now if we do await box v2 dot retrieve, to string, excuse me, we get 43, right? Because we call this increment function on it. So now, if we refresh, now we see, if we refresh our proxy, we see this upgrade function's been called. And what this did was it said, hey, old box contract, you gone. All right, you're no longer worth anything. And now that exact same address points to this new implementation. So we can again do box, await box v2 dot increment, and then we'll do our retrieve again, and now it's 44. Oh. If you want, I can go through showing the tests locally. If you want to see here, I'll even just pull up the full code example here, see what the tests look like. In the test that we do does exactly that, right? So we go ahead, we deploy our box with upgrades.deploy box. If we call increment, it throws an error. It says, what are you talking about? There's no increment function. We upgrade the box, then we call increment, and it's all good, right? So we can do npx add test. You can see those tests run. Artifact for greeter not found. Well, you shouldn't have a greeter artifact anyways. There. Artifacts are messed up. Oh, it's because I'm in the wrong, whoops. Code. I'm still in the, sorry. CD, code, smart contract. There we go. npx hardhat test. Now we're in the right folder. And my package.json has this weird thing on it again for some reason. Now it doesn't, and we see those two pass. Perfect. Okay. So I know we went over a lot, and I know this is some this is a little bit more advanced pieces. But how are people? Hopefully, people will be able to follow along. Are there any questions here? This is definitely some advanced stuff. This is that stuff that can take your project from being kind of cool to having this crazy functionality, having this really advanced technology here. And again, you can combine this with our DAOs. You combine this with other pieces to build upgradable smart contracts. So with that being said, any questions? Definitely got to come back to this. It's late. Need to go. Upgrade is something I'm really curious about. Awesome. Well, you came to the right place. A lot of those links to my videos, the OpenZeppelin blogs, will teach you more about these upgrades and these proxies, which are really this key piece to making this all work. Did you install OZ? Yes. It knows you're not loyal to JavaScript and makes you pay for it on live streams. I pulled this one together, right? I've learned basic level of programming through YouTube and school and stuff, but I've never done any real world stuff. How can I get started? Any places you guys suggest? This right here, these hackathons. It's these hackathons where people get hired, where you hone your skills, everything. If you're here at this hackathon, make the commitment to yourself. I'm going to submit something because that is the resume builder. When projects look to hire people, they look at your GitHub. They look at what you've done, right? What you're doing. And for yourself, maybe you don't want to get hired. Maybe you want to build your own protocol. The only way to get good at building protocols is to build more protocols. So jumping in, finding a team, networking, that's that other key piece, networking. That's how you really get started. And then just start applying to some protocols, right? Apply. There's a ton of blockchain groups and companies looking for talent. Start applying, jump into the scene. How does it store on the blockchain internally? Does it create a parallel ABI? No, it doesn't create a parallel ABI. I'm thinking you're talking about the Hardhat runtime. So Hardhat spins up like its own fake little blockchain, and then not in parallel, but synchronously it deploys to its own network. It just does it really, really fast because it's its own network. For when we deploy to Rinkeby, it actually just deploys one contract at a time. Right, and that's how that works. I'm not going to put that on the screen, but that's funny. How does the proxy pointing upgrade work? Doesn't the deployed proxy contract have to change after deployed? Or is the box contract address like an internal variable to the proxy contract? Yes, the latter. That is spot on. You exactly have it. So if we look at the proxy contract, you can see in here an implementation. Well, this is the implementation function here. Which calls to this another implementation function. Isn't that fun? Let's just look at it in here. Look at this function implementation. Function implementation. Here we go. Implementation. Okay, got another one. Function get implementation. Here we go. Okay, so it calls implementation, which calls get implementation, which gets this. So this is the function that points to whatever implementation contract we want to use. So we always call the proxy, and the proxy routes our call to that contract, but it pretends it has that function call, right? So if we were to call, store one in our storage, proxy will go, I'm going to take that logic for me. I'm going to store some stuff in my storage spot and then, give your function back to you. right? So it runs your function in the context of its own contract. And it's important to note that actually, because guess what? If you have a storage variable in the same spot that another contract wants to store storage to, you'll get what's called a storage collision or storage clash, right? And you'll just keep overwriting yourself, which is no good. So that's another reason why you don't have constructors in these. So it says, so this thing here, storage slot.get address at implementation slot. This is where it's getting that implementation. And when we call upgrade, it upgrades, it changes that address, right? So yes, it is literally just a variable in these contracts. So can the proxy itself be upgraded? Because as I understand, you can only change functions, right? So the proxy can't be upgraded. However, the implementation of the proxy can be upgraded, right? So am I with Google Draw? I'm not going to do Google Draw. So yeah, the proxy points to a contract. It says, hey, we're going to point to box. We say, we don't want to point to box anymore. We want to point to box v2. Now we point to box v2, right? We could have our proxy point to literally any other contract because we coded it to be, unlimitedly customizable. So we could say, okay, box, or okay, proxy, now you're going to point to, the Aave contracts or the Yearn contracts. And we could call functions as if we were Aave and Yearn. Now, obviously, we're not going to change any of their states because, we don't have the control. Our proxy doesn't have the control of them, but we could run those functions as if we were them, which is really cool. So the proxy itself can't be upgraded, but the contracts can. Now, this is where people are like, hey, I've already deployed this. Can I upgrade it later? And the answer is maybe, right? So one of the common ways people actually do upgrades is they do the social migration or the yeet method, where you basically say, hey, screw that contract that we deployed. This is the new real one, right? And this is a pretty common practice when you say, hey, this is Aave v1, this is Aave v2, this is Aave v3. Let's go to Aave v3 because that's the real Aave now, right? Or whatever. That's the social migration where you tell people, this new address is the right one. Now, if you've deployed a contract and you don't have people pointing to a proxy through there, then you have to do the social migration piece, right? Otherwise, if you deployed a proxy on top, then the user will never have to change an address because all you do under the hood is change, where the implementation is pointing to. Now, of course, this is a centralization vector, right? If you are the only one who can change where this proxy is, where this address is, it's a centralization vector, which is why I recommended, hey, if you want to make this truly decentralized, slap a DAO on top of it. Doing that is non-trivial. It's definitely a little trickier, and we don't have an example yet. I'm working on an example, but the Open Zeppelin Wizard has some pretty good upgradable DAO stuff that you can look at. That's really good. So it does add this centralization vector, right? And so when you're working with protocols and you want to think about decentrality, if a single person has the ability to upgrade a contract, you got to take that in mind with, okay, if they want to screw us over, maybe they'll just point it to a contract that says steal all your money, right? So these are things to keep in mind. Just got here, but could Chainlink be used? Great question, by the way. But could Chainlink be used to publish data from a company as a text file, maybe 200 lines of text? Yes. Check out Chainlink API calls. Absolutely. A dream in Patrick's voiceovers now. I'll try to make my voice a little bit smoother so your dreams are nice. This hackathon is life-changing. Great. Well, really glad you're here. Really glad to see what you build. Maybe I missed this, but what about the old contract? Will users still be able to interact with the old versions through Web3/Ethers? Yes, right? But remember, the storage, the state of our contract is actually stored in the proxy. So people can interact with that, with our implementation, right? But it's not going to do anything, right? They could call increment to the moon, right? And have our box implementation have value be 10 million, but our proxy is always going to be 43. because the storage, the state variables only get updated in the proxy and not the implementation. Because remember, when we call delegate call, when we call through the proxy, delegate call says, hey, I'm going to use your functions as if I had those functions. It doesn't care about what your state is, right? It's just the logic. And that's what we want, right? So that when we upgrade our smart contracts, we can upgrade the logic. Great question. Hopefully that answers it. If it didn't, please ask again. The contract can have a self-destruct function and you get some gas back. Sure. Sorry, I'm not sure what that was answering to. That's one way, but is it safe to trust a contract that can disappear if the owner decides to just destroy it? Spot on. Spot on. Probably not, right? So you want to keep this in mind when you're looking at these contracts, and there's actually a piece of this tomorrow with his opcodes talk. If you do create to and self-destruct can actually be another form of upgradable smart contracts, because create to can deterministically decide the address that a contract gets deployed to. So if you deploy a contract to one address, you destroy it, and then you redeploy an address to that same address with different functions. It could be, that could be considered like an upgradable smart contract as well. So these are all things you definitely want to keep in mind. Yes, that's the centralization vector. In a whole smart contract architecture, how to decide which contracts should be upgradable? This is another amazing question, and the answer is it really depends. So Trail of Bits is a fantastic auditing service, and they actually recommend nobody does upgradable smart contracts, right? Which sounds like, wait, what? But they say, that adds an unnecessary centralization vector. It adds unnecessary complications and complexity. And they argue nobody should do it, which is really interesting. Others say you can have it, but it should be a DAO that has it. Some say, if you want to have that centralization node, put it in. We showed how to do it with a Gnosis multi-sig, right? Which adds at least, a number of characters can be the ones to upgrade it. But the answer to that is it really depends on the architecture of what you're looking to build. Amazing question. Thanks for all the flattering comments. How soon do you anticipate? Oh, no, that's sooner than you think, but not as quick as you'd like. Off topic, but have you ever used IPDB or BigChainDB for storing data? I was considering using one of them. I haven't. I've worked with Filecoin, which is great, Arweave, obviously IPFS, Skynet, OXChain. There's a lot of great decentralized storage options. I've obviously used a number of centralized storage options as well. But yeah, a decentralized database with Chainlink is like crazy powerful because you can store your stuff in your database and you can pull it on your smart contracts with Chainlink and you do really cool stuff. But I have not. So great questions, everybody. Are there any other questions here? So these have been fantastic questions. I know we're at time. Happy to finish answering anything else. I know these proxy things are a little bit tricky. For those of you who are interested, of course, shilling Python here. I of course did this in Python as well. We are doing the Pythonic version of this tomorrow, where we're going to go through these upgrades in Python. But yeah, today was JavaScript, and definitely take a look at that repo and fork it, clone it. See if you can run the tests and have fun there. So, would you recommend JavaScript or Python to get started? It doesn't matter, right? I make a lot of jokes about JavaScript, but it really doesn't matter. Like 75% of the blockchain community right now works with JavaScript in some capacity. So it literally doesn't matter. Pick one and go. Don't let that be the thing that stops you. Pick one and go. The solidity is going to be the same no matter what you use. So what are the biggest threats to DeFi? I don't know. People using itself. Actually, honestly, itself. People using insecure oracles and getting hacked for $130 million or $600 million or whatever itself. Like we as a community are not as mature as we should be, and we're getting there. We're getting better, right? In a weird way, each one of these hacks makes us better. as like a immunity, right? As like it's like a shot, right? So right now I think it's just ourselves, and if we continue to keep ourselves to a higher standard and get hacked less and build better protocols, I don't see anything stopping us, right? So I see DeFi's biggest threat being itself. I think there's definitely regulation is going to come into the play at some point. But for the most part, I see it. I don't see that. I see that being an obstacle, but I don't see that stopping anything. This isn't going away, basically. So DeFi, it's not a matter of if, it's a matter of when, and it's how quickly we can pull ourselves together. Get some sleep. I've seen. I'm not going to say that because I'm going to butcher it. I'm sorry. I've seen this person talk about the use of Oracle for decentralized journalism on Twitter. What do you think about that? That sounds really cool. That sounds really cool. And that's another one of those things where it's not a matter of if, it's a matter of when. Journalists collect real world data. Oracle's put real world data on the blockchain. Boom. So, any functional programming language coming up like Cardano using Haskell? Great question. So Chainlink and Cardano are there's an integration planned at some point. I mean, Chainlink is blockchain agnostic, so technically you could probably use it right now if you wanted to just do the actual legwork to make sure everything worked correctly. But so once those are up and going and once things look good, you'll probably be seeing some Haskell out of us. So I'm gonna have to learn Haskell. Favorite resource for learning React? I am a big fan of YouTube Academy, hence why I make a lot of YouTube videos myself. Whenever I'm trying to learn a new resource, I'll jump on YouTube. I'll look up blogs. I think I did take a couple of Udemy courses myself, but I think I got a lot more mileage out of just like following a ton of React tutorials and then making a ton of Stack Overflow questions. Ton of Stack Exchange, Ethereum questions as well. Joining the community, ask. So also, if you're looking for morale stuff, for React stuff, Moralis has some really sick tools, and I'm probably going to be working with Moralis a lot more in the future. Can we get another workshop to do this upgrade with a use case of multi-signature from different owners and manage conflicts on votes and that stuff, please? Probably. And actually, though, so I just posted a link to the Open Zeppelin blog on doing these upgradable smart contracts with the multi-sig. So they use the Gnosis safe. I know I showed how to make a Gnosis safe here, but I didn't actually transfer ownership to the Gnosis safe. But that blog will show you exactly how to do that. And that's really powerful, right? Because if you have a small, tight-knit community, maybe you want to, give that treasury to a multi-sig, right? Maybe you're not ready for full DAO, full decentralization yet, which again is totally fine, right? A lot of protocols, they need to take baby steps going from centrality to decentrality. A lot of them do it. It's okay. But yeah, that blog will show you exactly how to do that. Great questions, everybody. Are you ever planning on making courses on Rust? We actually have some out already. So Harry has a couple vids and a couple blogs on Rust that are really good. And we're definitely going to be having more, right? Because Rust is a fantastically performant language. It's used in a lot of blockchain technologies. So you'll probably be seeing more. I know Hardhat is actually doing some Rust stuff right now, which I'm really excited for. So probably. Great questions, everybody. Okay, cool. Well, we are a few minutes over. Thank you all so much for being here. I hope you all learned a lot. Feel free to jump into that GitHub, leave some issues on it if something doesn't make sense. Again, let me put the feedback form. Feedback. Remember, please take the feedback form if you're looking for to let us feedback. These are how we make these as good as possible. And if you want to learn more about these upgrades, definitely check out my YouTube video as well. We talk about the proxies and we talk about these different migration methods as well. And we do it in Hardhat. We do it with Nodes to Safe as well. So hopefully you all learned a lot. Thanks so much for being here. And we will talk to you tomorrow. Tomorrow morning, brownie version of this. Very excited for that. See you there.